Authored by a veteran chemistry teacher, Abdul Shakur, these two textbooks provide all the essentials that would not only enable students to master grade 11 chemistry, but to excel at the next higher level in this subject. What make these texts unique are their creativity and profundity with which concepts are explained for clarity and mastery. The following is one of a set of 44 different tutorials created by the author, using materials primarily from the text Chemistry 11 in Focus. I hope you enjoyed this video. If you liked it, please give it a thumbs up and don't forget to subscribe. We will see you in the next video and thank you for watching.
Today our lesson deals with calculating ion concentrations in aqueous solutions, of course, of ionic compounds. It starts on page 216 and ends on page 222 from the text Chemistry 11 in Focus. We'll be looking at equations for the dissociation of ionic compounds, calculation of molar concentration of ions in aqueous solutions, and dilution of a stock solution. The following are examples of how a few ionic compounds dissociate when you dissolve them in water. Here you can see 1 mole of sodium chloride dissociating to give you a mole of sodium ions and a mole of chloride ions here. So if you look at this figure here, you can see how sodium ions are attracted to the chloride ions there. So if you have 1 mole of that and you break them apart, you will end up with 1 mole of sodium ions and 1 mole of chloride ions. So you look at the formula here, okay, and you can look at the subscript there. When you do not see a subscript, it is indicating to you that 1 is there. And that tells you how many moles of these ions will be formed. Look at this one here, next one. Next one shows you how a mole of calcium chloride dissociates in water. You can see a subscript of 2 there, right? That is telling you that you're going to have 2 moles of chloride ions and only 1 mole of calcium ions there. So same thing we're doing with this figure here. You can see how in this 1 mole of calcium chloride, you're having 1 mole of calcium ions here connected to 2 moles of chloride ions. So when they dissociate, you'll have 1 chloride there, another chloride here, and then this 1 mole of calcium there. So that's 2 examples you're given there. Another one comes here, where I'm showing you how you're using one with a radical. Okay, here is your sulfate radical. I just want to remind you that the radical consists of a number of atoms bonded together by covalent bonds. Here you're having a sulfur atom here bonded together with 4 oxygen atoms there. So when these guys move, you don't break them up, they move as a radical there. Okay? So now you can see you're going to have only 1 sulfate ion there, and so if 1 mole of this dissociates, you're going to get 1 mole of sulfate ion. But now you're seeing a 2 there, a subscript of 2 with the sodium ion there. So in this case, like the case before, we have 2 moles of chloride ions. Now you're having 2 moles of sodium ions. And here you see I've done that for you here. All of this is in one package here, okay? They're all bonded together, so that's 1 mole. But when you dissociate it in water, they separate out into 2 moles of sodium ions, 1 mole here, 1 mole here, and 1 mole of sulfate ions there. Give you another example here with another radical. Here you're having aluminum nitrate dissociate in the water. But now look what happens. You're having 3 moles of nitrate ions though, right? So you have 1 mole of aluminum ions, but with 3 moles of nitrate ions. And again, nitrate ions move as a block. All the atoms are bonded together. In this case, 3 oxygen atoms bonded to 1 nitrogen atom there. So all of this before was 1 mole, okay? And when you dissolve it in water, they dissociate, and you get 3 moles of nitrate ions and 1 mole of aluminum ions. I like to use baby doll to explain this concept. You know, in a factory, they make these baby dolls by popping on the head onto the torso, the 2 legs, the 2 arms, and you end up with 1 baby doll. If you have a mole of baby dolls and you dismember them by popping off the heads and the arms and the legs again, you will end up with 1 mole of heads, 1 mole of torsos, 2 moles of arms, and 2 moles of legs. You can also use the human body to teach this concept. If you have a mole of human bodies, you can identify 1 mole of heads, 2 moles of arms, and 2 moles of legs, and 1 mole of torsos. Even the head can now further be used to do some more calculations of smaller parts there, right? Every mole of head, you have how many moles of eyes? 2 moles of eyes, 1 mole of nose, 1 mole of tongues, 2 moles of ears. Don't try doing it for teeth though, okay? Because you'll have lots of discrepancies there. People lose their teeth. So what we have here is another illustration of this concept, but we're now putting them in the solution. So we're actually having 2 compounds there being dissolved in a liter of solution. So the number of moles in this case is 1 mole of calcium chloride, and the volume of solution that we're using is 1 liter. So the concentration is equal to N over V, C is equal to N over V, and my concentration there is 1.0 mole per liter. So look what happens. This is how calcium dissociates. For every 1 mole per liter of this here, you end up with 1 mole per liter here and 2 moles per liter of the chloride ions. Now the example across here, we're using sodium sulfate now. That's the number of moles, 1 mole in 1 liter. Concentration, divide number of moles by the volume. We end up with 1.0 mole per liter. And look what happens. This 2 here gives you 2 moles of sodium. So it'll be 2 moles per liter of sodium. And this is 1 mole per liter of sulfate there, okay? So this is another way of showing you how these things are actually dissolved in a certain volume of solvent. You calculate the concentration, and then you can know what the concentrations of the ions there, all right? What do you have here? So you have some problems for you to do the dissociation equation. That is in the manual. Now we talk about ionization versus dissociation. You're going to have some molecular compounds that ionize in water. One of them is sulfuric acid. When sulfuric acid ionizes, 1 mole of it produces 2 moles of hydrogen ions and 1 mole of sulfate ions. But this is not actually correct. When you do acids and bases, you see only the first mole of this ionizes completely. And then you're going to have HSO4, which is only 20% ionized. But it has the ability to be fully ionized. We'll talk about that later on, okay? So if we give you something like this, we're assuming that sulfuric acid ionizes completely. We're getting 2 full moles of that and 1 mole of that. And here they give you that again, to do something like that. Some more to show the ionization equation. Now we're going to show you how we go about calculating molar concentration of ions. Okay? So we do a real problem here. Here they're giving you 12.01 grams of sulfuric acid, and it is dissolved to make 200.0 milliliters of solution. Again, I'm telling you, we're assuming complete ionization of this thing. So your equation will be this. Okay, watch this. I've done some colors here for you because it's important for what we're doing later on. Okay, this is your parent molecule. Your parent molecule has that color. Okay, when it ionizes, it produces 2 ions, these ones and these ones here. So what? Every 1 mole of sulfuric acid produces 2 moles of hydrogen ions and 1 mole of sulfate ions. That is a mole ratio. But we do not have 1 mole. We have a fraction of a mole. So we have to change this to moles and then divide by that to change it to concentration. Let's see what is the molar concentration of the parent molecule. In this case is sulfuric acid. Number of moles, of course, always quote it. If you keep quoting that, there's no reason why you shouldn't memorize that quickly, okay? This is the mass here. That's the molar mass of sulfuric acid. So that's the number of moles. So in that 200 milliliters, you'll have this amount dissolved, right? So what is the concentration now? Concentration, number of moles divided by the volume. First of all, you change the volume from milliliters to liters, and that's what you get there. Then C now is equal to N over V. N is this, V is that, and you end up with this. So look at the different colors that I have. So I'm having this color here to show what mole ratio of ions are produced when the parent molecule ionizes. And this one here is the actual concentration of the molecule that you're dissolving. Okay, this is the actual concentration. So if you want to find now the concentration of the hydrogen ion there, we are not dealing with 1 mole per liter of that. We are dealing with this number of moles per liter. Okay. Then what do you do? When you calculate this, you put it at the side here, okay, here. Then, of course, that is moles per liter of sulfuric acid. And you multiply by the mole ratio of hydrogen. What's the mole ratio of hydrogen in this equation? It's 2 moles of hydrogen to 1 mole of sulfuric acid. So this is the mole ratio you multiply the calculated concentration of the sulfuric acid by to find the concentration of hydrogen ions present in the solution. Again, take this guy what you calculate there, put it at the side there. Sorry about this shift. So that is for sulfate ions, and you multiply by the mole ratio now of this. What is the mole ratio of this? It's 1 over 1. So that's the mole ratio here, okay? It's 1 over 1 of sulfate to sulfuric acid, and this is what you get. Of course, you expect this one here to be twice this one, and that is exactly what you have. So one more time. You're given a mass of the molecule that is being dissolved. In this case, sulfuric acid, that's the mass. And they're telling you the total volume of solution that you'll end up with. First thing you do is to take your molecules and ionize it to show the specific mole ratios of ions, okay? Then you calculate its number of moles by dividing its mass by its molar mass. Then you calculate its concentration. First of all, you change the volume from milliliters to liters. Then you find its concentration by dividing its number of moles by the volume of solution there, and you end up with that here. Okay? This is the concentration of your sulfuric acid. Now you have to go about finding the number of moles of these two ions here that are produced when that concentration there of sulfuric acid ionizes. So what you do, you take that amount that you calculated, put it aside here, and multiply by the mole ratio of the ion that you want to find out, as given by this equation here. It'll be 2 moles of hydrogen ions for every 1 mole of that, and you multiply by this, and you end up with this. Same thing for sulfate now, but only thing your mole ratio is 1 to 1, and that's what you have there. All right, next. You're given a few to do there. All right, practice those. What happens when you dilute a stuck solution? Let's look at these 2 aquariums here with goldfish inside. Okay. In this aquarium here, we're having 10 fish inside and a volume of water V. Now we double the volume of water to make it 2V, and the same number of fishes inside here, right? So the fish have a bigger place to swim. What do you think about the concentrations in A and B? See? this will be of a lower concentration than that. But look, when we're diluting this, we did not change the number of fish inside. They still remain 10 in both cases. Same thing will happen when we dilute a stock solution or a solution that is concentrated with a certain number of ions, and we dilute that. We're not changing the number of ions, but we're giving the ions a greater volume of solution in which they can swim. So look at this situation here. Same thing like that one, the goldfish, right? Inside here, we are having 12 particles, okay, in a volume of V. Now we are having 2V, but we did not interfere with the number of particles. The number of particles stay the same. So the underlying point I want to make here is that the number of moles of particles remain the same after a solution has been diluted. All right? So let's look at a real problem when you dilute a solution. And how do you go about finding the final ion concentrations in the diluted solution? So here again I have another illustration. This problem here entails this one here, where you're having 200 milliliters of 4.40 moles of sulfuric acid, and look, you're diluting it to 800 milliliters. All right? You want to know what will be the final concentration of the solution. So initial concentration, something I call it C1, and they call that V1 here. All right? V1 is this, C1 is this, V2, they'll call this V2, yeah, that's V2, and they want you to find what is the final concentration, C2. Okay. Remember, I established the point that the number of moles before, okay, N must be equal to the number of moles afterwards. So what we are saying, the number of moles in any situation is given by C times V. So if you have a certain number of moles here, it will be found by multiplying the initial concentration by initial volume here. And since we did not change the number of moles here, it will be found by multiplying the final volume by the final concentration. So we equate these two equations. We equate these, see? So this here is the same, and this here is the same. Therefore, this must be equal to that. So when we equate these, we'll have this equation here, where C1 V1 is equal to C2 V2. Now we're interested in the final concentration. We're interested in C2. So how do you do that? Very easy, maths. Leave this as it is, block this one off, and you bring this guy to the bottom there, okay? So C2 will be equal to C1 V1 over V2. If you wanted V2, you leave V2 there and you bring down C2, okay? If you want to find C1, let's say a different problem, you want to find C1, you leave C1 there, leave these two, and you bring down V1. If you want to know V1, leave these two there, and you bring down C1. You're given 3 of these, you can find the 4th one. C2 will be equal to C1 V1 over V2, and that's the final concentration there. Quickly, with the diluted solution, the number of moles do not change. The only thing that change are the concentrations and volume here. C1 V1 must be equal to C2 V2, and therefore, knowing 3 of these quantities, you can find the 4th one. Another problem here, look, this is what is required, and now you're diluting this stock solution here. You want to find what volume of the stock solution must be diluted. In your lab now, you want to make up that solution of HCl to do an experiment, right? But here you have a bottle in your lab that says 10.0 mole per liter HCl, right? Now you want to pour off a little bit of that into a small container here, and then you want to make 2 liters of that. So you get a 2-liter volumetric glass now. So what you do now, you put in a little bit of water inside there. We talked about this yesterday. You should also put this in a water bath here. That's cold water outside there. and then you use a funnel here, and you gradually pour whatever you calculate here into that. After you do that, you fill it up with water, dilute it to that, and that's where you get your 2 liters of that solution here. I hope that helps. This, of course, is a what? That will be a C1. That's the initial concentration, because that's a guy you're diluting, okay? This one here will be a V1. And of course, you want to achieve these, so that will be V2, and that will be C2. Now, our objective is to find what is V1. So we know this, and we know this. Use this equation here now. C1, V1 equals C2, V2. And what are we looking for? We're looking for V1. So make V1 subject of the equation. Leave these two as they are. And you bring down your C1 there. And then you put in your values there. And that is the volume of your concentrated HCl that you're supposed to pour off. And then you use that to make your 2 liters of your solution. And here I've given you a note again how to dilute acid, okay? Never pour water into the acid. Always pour the acid into water till that's in a cold water bath. Next. Okay, got another problem now. Okay, this is nice. You have that mass of calcium nitrate, and you put it inside that volume of solution. They want you to calculate what these concentration will be if it is diluted further to 2 liters. So first of all, we find the concentration of the solution. Then we'll dilute it to find the final concentration. Then we'll go about finding the concentration of these 2 ions in the final mixture. Find number of moles first. N, mass over molar mass. That's the mass there. Divide by the molar mass of calcium nitrate, which is this, and you end up with that number of moles. Now you're dissolving that in 200 milliliters. So find the concentration there, change 200 milliliters, the liters. That 200 milliliters became that number of liters. And that is the initial concentration of your calcium nitrate. So what are they telling you now? You're diluting that to 2 liters. So you do again C1 V1 equals C2 V2. Now you want to find the final concentration, all right? This. Leave these there as they are. Bring down V. And this is how you get the final concentration. Now you do your dissociation equation to see how this dissociates. 1 mole per liter of that dissociates to give 1 mole per liter of this and 2 moles per liter of that. But this is what you're interested. This is what we talk about. So now you'll put this here and you multiply by the mole ratios there. Number of moles of calcium will be equal to, I told you, this is what you calculated for the concentration of the parent compound, in this case the calcium molecule, because it's this. And you multiply by the mole ratio here is 1 mole of calcium for 1 mole of that, and you end up with that concentration of calcium ion. Obviously now, because you're having 2 moles of nitrate for every 1 mole of this, you'll have this, twice that volume. So that is how you go about finding the final concentration of a compound after it has been diluted, and also how you find the concentration of the ions in the final solutions. Okay? So these are some questions for you to do. You have anything more? Nothing more. And these can be found in your solution manual, so the answers to these. Alright. So I think everything was straightforward there. Alright. Quickly, a quick recap. To find the concentrations of any sets of ions, first of all, you do a dissociation equation to show you the mole ratio of the ions. Okay, that is good. If they give you a mass and a volume, you calculate the number of moles of the substance, and then you calculate its concentration. We'll use this problem here to exemplify how this is done again. So they give you this sulfuric acid, for example. They'll give you that mass and that volume, okay? So first of all, you show the dissociation equation to show the mole ratio. Secondly, you find number of moles of the compound is Total mass over molar mass, you get that. Then you find its concentration. Find its concentration here. Okay, using this equation here. And that is the concentration of the parent molecule. Now you use this here now, and you multiply that by the specific mole ratio of the ion that you're talking about. So if you're dealing with hydrogen here, you take this and multiply it by the mole ratio of the ion there. Okay? And then this one here, multiplied by emulsion. When you dilute solution, when you dilute a solution, the number of moles of particles stay the same, but only the volume changes here and the concentration change. So they can ask you to find a number of things that can give you the initial volume and the initial concentration. Then they can tell you the final volume and ask you to find the final concentration. In that case, it is C2. So knowing that, we will say that C1 V1 is equal to C2 V2 because number of moles don't change. And any one of these you can find. You're given these and one of these here, you can find the third one. And that's how you go about doing this type of problems. I hope that was useful to you. See you again.